what we want to do is we want to give you an understanding of the role computation can and cannot play in tackling technical problems, so that you will come away with a sense of what you can do, what you can't do, and what kinds of things you should use to tackle complex problems. And finally, we want to position all students so that you can easily, if you like, compete for things like UROPs and summer jobs, because you'll have an appropriate level of confidence and competence in your ability to do computational problem solving. So those are the strategic goals. Now, this course is primarily aimed at students who have little or no prior programming experience. As a consequence, we believe that no student here is underqualified for this course. You're all MIT students. You're all qualified to be here. But we also hope that there aren't any students here who are overqualified for this course. And what do I mean by that? If you've done a lot of prior programming, this is probably not the best course for you. And if you're in that category, I would please encourage you to talk to John or I after class about what your goals are, what kind of experience you have, and how we might find you a course that better meets your goals. Second reason we don't want overqualified students in the class. It sounds a little nasty, but the second reason is an overqualified student, somebody who's, I don't know, programmed for Google for the last 5 years, is going to have an easy time in this course, but we don't want such a student accidentally intimidating the rest of you. We don't want you to feel inadequate when you're simply inexperienced. And so it really is a course aimed at students with little or no prior programming experience. And again, if you're not in that category, talk to John or I after class, and we'll help you figure out where you might want to go. Okay, those are the top level goals of the course. Let's talk sort of at a more tactical level about what do we want you to know in this course? What do we want you to be able to do by the time you leave this course? So here are the skills that we would like you to acquire. All right, the first skill we want you to acquire is we want you to be able to use the basic tools of computational thinking to write small-scale programs. We're going to keep coming back to that idea, but I'm going to call it computational thinking. And that's so you can write small pieces of code. And small is not derogatory here, by the way. It just says the size of things you're going to be able to do. Second skill we want you to have at the end of this course is the ability to use a vocabulary of computational tools in order to be able to understand programs written by others. So you're going to be able to write, you're going to be able to read. This latter skill, by the way, is incredibly valuable, because you don't want to do everything from scratch yourself. You want to be able to look at what is being created by somebody else and understand what is inside of there, whether it works correctly, and how you can build on it. This is one of the few places where plagiarism is an okay thing. It's not bad to, if you like, learn from the skills of others in order to create something you want to write. Although we'll come back to plagiarism as a bad thing later on. Third thing we want you to do is to understand the fundamental both capabilities and limitations of computation and the costs associated with them. And that latter statement sounds funny. You don't think of computation having limits, but they do. There are some things that cannot be computed. We want you to understand where those limits are. So you're going to be able to understand abilities and limits. And then finally, the last tactical skill that you're going to get out of this course is you're going to have the ability to map scientific problems into a computational framework. So you're going to be able to take a description of a problem and map it into something computational. Now, if you think about it, boy, it sounds like grammar school. We're going to teach you to read. We're going to teach you to write. We're going to teach you to understand what you can and cannot do. And most importantly, we're going to try and give you the start of an ability to take a description of a problem from some other domain and figure out how to map it into that domain of computation so you can do the reading and writing that you want to do. Okay, in a few minutes, we're going to start talking then about what is computation, how are we going to start building those tools, but that's what you should take away. That's what you're going to gain out of this course by the time you're done. Now, let me take a sidebar for about 5 minutes to talk about course administration, the administrivia, things that we're going to do in the course, just so you know what the rules are. All right, so class is 2 hours of lecture a week. You obviously know where and you know when, because you're here. Tuesdays and Thursdays at 11. 1 hour of recitation a week on Fridays. And we'll come back in a second to how you're going to get set up for that. And 9 hours a week of outside the class work. Those 9 hours are